So the fourth root of y has to stay. There is nothing we can do to that. But the fourth root of 81 is
81, 1 over 4. So 1 over 4.
no. I have to ask myself which number I raise to the fourth power to get 81. And the answer is because it's 9 times 9. Two threes in one 9 and 2 3s in another. So it's 3 to the fourth. So this is 3. And multiplied by the fourth root of x to the fourth, which is x. It would have been the absolute value of x in case we're told that x can be any real number. Very good. So now we can move on. Let's say problem 27. So in 27, the square root of 5x squared divided by 4y squared. Please split it and simplify it, assuming all variables are positive. Do we have an answer? Yes, but it's not 5, it's the square root, so that's why I will put x in front and the square root of 5 at the end. And then, yes, assuming that variables are positive. Otherwise, I would have used the absolute value on x, and I would have used the absolute value on y. Correct? Okay. I would like to move on to problems 31 through 60. These are very important problems. So let's start. I would like to start with 41, where we have the cube root of 16y to the 7th. The first step I would do what? Can anyone suggest? What would be the... Exactly. Because I don't want to deal with too many things at the same time. So I want to deal with the cube root of 16 first and with the cube root of y to the 7th next. Since I know that the cube root of 16 is not an integer, I'm thinking of splitting 16 into something times something else, and one of them is a perfect cube. And of course, I need to multiply them. The same thing with y to the 7th. So I will have y to a power times y to another power. And we'll discuss the power in a minute. So how do I present the cube root of 16? I need a perfect cube and something that is not a perfect cube. Very good. 8 and 2. Excellent. So 8 and 2. I agree. We'll rewrite the whole thing in a minute. Now, remember what we did a few minutes ago. 7 divided by 3 is not an integer. Go back 1. Is 6 divided by 3 an integer? So this is what I need. So what do I need? Y to the...
6.
Very good. And y to the...
First.
Yes. because y to the 6th times y will be y to the 7th. Now I will rewrite the whole problem. Here's how I rewrite it. Can you skip this step? Yes. If you're comfortable with it, I'm okay. So I have the cube root of 8 times the cube root of 2 times the cube root of y to the 6th and times the cube root of y. Now, here's a common mistake, and please pay attention. Here's a common mistake. Some students write this. The square root of 9 is the square root of 3. Is it clear that it's not possible, right? Once you apply the square root of 9, the square root is gone. There is no more square root. I saw it like in other papers, x to the 8th. Students write this is the square root of x to the 4th. No. 8 divided by 2 is already done. The square root is gone. So the answer is x to the 4th. So this and this will come out of the radical. No radical anymore. But these two have to stay. So I will have the cube root of 2y, and nobody can simplify those. But what is this? After I apply the cube root, I get 2. What is this after I apply the cube root? Very good. So 2y squared times the cube root of 2y. That is the final answer. And now I would like you to work on one. I promise, Jason, and I can't forget that. I promise. So the square root of 25, a squared, b to the 3rd. So let's work on this for a minute. And then I would like to work on 59. I'm copying it here. You don't have to copy it right now. The 4th root of 32, x to the 12th, y to the 5th. Can anyone give us the first step in 47? I agree. Because I don't want to work with more than one, but it's not mandatory. If you can write the shortcut, that's fine. So what do I know so far? I know 5. I know a. But I know that 3 over 2 is not an integer. So I have to split this into what? Give it a shot. Yes, b squared and b. So now the new, or this next step if you want, will be indeed 5a. But this will be the square root of b squared times the square root of b. And we know that if b is positive and a is positive, then this will be 5a b. Excellent. So let's work on 59, please. And that's final. But remember, if I'm told that a and b can be any real number, I would have to use the absolute value on the product ab.
Is that a b?
Yes, I'm sorry, forgive me. $59, the 4th root of 32, x to the 12th, y to the 5th. I know you're going to do this, I hope, first. And I'm just going to ask a question and then shut up for you to work on this. Which of these three radicals is friendly? Yes, Mike?
Wait, on the last question, what does
Yes.
b squared go away?
It doesn't. The square root of b squared is b.
Okay. So those mean the same thing?
The square root of b squared is b. Yes, yes. So which of these three radicals is friendly, does not need any effort? Which one? The one in the middle. This is the only friendly one. The other two need work. So what would you say about 32? Excellent. What would you say about y to the fifth?
Y to the fourth and y.
Excellent. I recommend, in order not to miss anything or forget or drop anything by mistake, I recommend rewriting it. Of course, it's up to you. So the fourth root of 16, the fourth root of 2, the fourth root of x to the 12th, the fourth root of y to the 4th, and the fourth root of y. Which radicals will disappear? 1, 2, 3, 4, 5. Will 1 disappear?
Yes.
Good. Will 2 disappear? No. Will 3 disappear?
Yes.
Yes. Will 4 disappear? Yes. But the fourth root of 2y have to stay. Those two have to stay. So please simplify the first. Please simplify the third.
Oh, I see.
Please simplify the fourth.
Y.
Any questions? Any questions? Any questions?
Why did you,
Yes.
how did you get that? You went through that again?
Yes. From the beginning?
No, just from the last.
From here? Okay. So the fourth root of 16 is 2. The fourth root of x to the 12 is 12 over 4, which is 3.
So why did we skip 2 things?
It's right here.
Okay, okay.
And the fourth root of y to the 4th is y. And these two are here.
Okay.
Better?
Yeah.
Perfect. Okay, 61 through 76. And then we'll talk about the distance formula and the midpoint formula. 67. So again, this is page 610. X to the 5th, y to the 3rd, divided by the square root of xy. Allow me to do your attention before we start working on this problem. I would like to show you, by comparison, two different situations. This is one situation in which I want to rewrite the whole thing with one radical. Why? Because I see common factors. I see x top and bottom and y top and bottom, and something will go away. However, if I have the square root of 5 over the square root of 3, there is no point in writing 5/3 under the square root. This is correct, but it will not allow us to further simplify it because 5 and 3 don't have a common factor. So there is no need to do this when there are no common factors. But here I have both x and y. So I will rewrite the whole thing with one radical. Simplify inside and then try to simplify the radical. Can anyone tell us what we have under the square root? To the excellent times. Very good. Now if you split this or you don't, you should come up with what? Both are friendly. You can split them, square root of x to the 4th and the square root of y squared.
To the second times y.
That's it. Now, let me choose another for you. let's say 71, in which I have 3 outside, and then multiply by the square root of 100x squared, and everything divided by 2 times the square root of 2x to negative 1. I do not recommend you simplify anything under the square root. Just change it into the same square root, because 102 have a common factor and x common factors. And then deal with the final simplified form later. So, please use this procedure. And let's see what we get. I will write 3 over 2. That's what I will write first. Then I will write the square root of 100x squared over 2x to negative 1. 3 over 2 will stay. So now this is the square root of 50. Careful. From the exponent of the numerator, I subtract the exponent of the denominator. X cubed. Very good. Thank you. So 3 halves, the square root of 50, and the square root of x to the third. Both roots need attention. So say it again. Very good. And this? Very good. I recommend rewrite this step. 3 over 2, the square root of 25, the square root of 2, the square root of x squared, the square root of x. You know now which radicals will go away. Which radicals will go away? First and the third. Very good. So what is the simplified form? 3 halves in front, 5, this x, and these 2 go back to under the root. But I have to multiply because it's 3 over 2 and 5 over 1. So this is 15 halves x, the square root of 2x. Any questions? Any questions? Okay, let's work on one more, and then we talk about the distance formula and the midpoint formula. 75. The fifth root of 64 x to the 10th y to the third, everything divided by the fifth root of 2 x to the third y to negative 7. So let's work on this for 1 minute. We have homework due on Thursday. It's posted from last week. Please don't forget. No, October the 13th. Is there a point in writing the same radical or not? Yes, because I see 64 and 2 have a common factor, x and y. Good. So this will be the fifth root of, I agree, with 32. I agree. Y to the? Very good, excellent. Do you all agree with 32, x to the 7th, and y to the 10th? I claim that 2 of these are nice and friendly, and 1 of them is not. So I have the 5th root of 32, I have the 5th root of x to the 7th, and I have the 5th root of y to the 10th. 2 are nice, 1 is not. Which one is not?
X.
Yes, this one is not. This is nice, this is nice. Therefore, I have to split x to the 7th, because 7 divided by 5 is not an integer. Four and 3 will not work because 4 is not divisible by 5 and 3 is not divisible by 5. Very good. So x to the 5th and x squared. I recommend rewrite. One more time. The 5th root of 32, the 5th root of x to the 5th, the 5th root of x squared, and the 5th root of y to the 10th. Only this radical will stay as the 5th root of x squared. Everything else will go away as a radical. 2 indeed, x indeed, and y to the 2nd power. So from here, 2. From here, x. From here, y squared. And from here, it has to stay. Okay. Distance formula. And midpoint. The distance formula and midpoint. Assuming we have the following scenario. Oh, I forgot. This one is not working. Okay. Oh, I forgot. This one is not working. Okay. So let's say we have a point, point A, and we have another point, point B, and we want to determine the distance of the segment between A and B. So first of all, I will form a right triangle with a horizontal line and of course a vertical line. This will be a right triangle. I am going to denote the coordinates of point A, x1, comma, y1. What do you think I'm going to denote the coordinates of B? Of course. So now, what is this? What is this? What is this? And what is this? You cannot give me numbers. You have to give me what you see here. A, x1, comma, y1. How much is this? X1. Very good. So how much is this? Very good. How much is this? Y1. And how much is this? Y2. Therefore, what is the length of this leg? What is the length of this leg? What is the measure of this leg? Knowing that this is x1 and this is x2.
X2?
Yes.
X1.
Say it again.
X2 minus X1.
Very good. Chris, you wanted to say the same thing? Okay. So can you tell us then what is this? So there is a right triangle with the following dimensions. One leg measures y2 minus y1. The other leg measures x2 minus x1. And the hypotenuse measures d. Do we know a theorem that is applicable in a right triangle? Very good. So the leg, let's start with the hypotenuse. The hypotenuse squared equals x2 minus x1 squared, and then plus what? Excellent. Pythagorean theorem. Good. Now we take the square root from both sides. Take the square root from this, and I take the square root from the other side. The left-hand side is d. Please remember what we are allowed and what we are not allowed to do in a radical. So can I simplify the right-hand side? Don't say anything before you go back and check. And remember the properties or the laws. Can I simplify the right-hand side, which is the square root of this squared plus this squared? Can I simplify it? No. Very good. I'm not allowed to because it's a sum of two quantities. So this is x2 minus x1, everything squared, plus y2 minus y1, everything squared. No one can simplify this any further. And this is what we call the distance formula. Now, one other detail here is that right in the middle of this segment, line segment connecting A and B, right here, right in the middle, we have what it's called the midpoint. This point bisects or divides, if you want, the segment, the line segment, into two equal parts. In order to determine the coordinates of that point, all we have to do is average the x value coordinates. So x1 plus x2 divided by their number. The same thing for y1 plus y2 divided by their number. And now I will ask you to pick two ordered pairs so we can determine the distance and the coordinates of the midpoint. Any two ordered pairs that you can think of, so we can find the distance and the midpoint. Yes. 1, 1, 2. Okay. 1, 2. Negatives and 3, -5. Perfect. So we are given two ordered pairs. We are asked to determine two things. Number one, find the distance between these 2 points, and then find the midpoint. Let's start with the midpoint because it's the easiest thing to do. Please add these two values up. Divide that by 2. Please add these two values. Divided by 2. We already determined the midpoint. Add the two x values and divide by 2. Add the two y values and divide by 2. Now we're asked to find the distance. I'm going to write the distance formula as x2 minus x1 squared plus y2 minus y1 squared. I am going to label the points as x1, y1, and x2, y2. I'm going to write those numbers under the corresponding notation. So x2 is 3, x1 is 1, y2 is -5, y1 is 2. And then I'm going to perform the calculations. How much is 3 minus 1? Please square 2. Very good. I reached this point. I cannot see negative numbers under the square root because whatever you get here, you have to square it. And then you have plus. Whatever you have here, you have to square it, right? So -5 minus 2. -7 squared. That's it. So D equals the square root of 53. So the distance between these 2 points is the square root of 53, and the midpoint is 2, -3/2. Any questions? Okay, I'd like to choose one more ordered pair. Let's say 95. The square root of 2, 3, the square root of 5, and the square root of 2, -2, the square root of 5. They're asking us to find the midpoint. Just the midpoint here. When I add the square root of 2 to the square root of 2, what do I get? Careful. When I add an apple to an apple, how many apples do I get? 2. So I have 2, the square root of 2 that needs to be divided by 2. When I add 3 the square root of 5 to negative 2 the square root of 5, 3 apples minus 2 apples, because they are like radicals, I get 1. So this is the square root of 5 over 2. The only thing I can do is simplify the 2's here. That's it. So the midpoint is the square root of 2 comma the square root of 5 over 2. Okay. Let's determine one more distance. Let's say 81. So negative 9 comma 4 and negative 8 comma 1. So please find the distance. 2 minutes, 1 minute. Remember to write the formula. Label the point or its coordinates. x2 minus x1 squared plus y2 minus y1 squared. If you like to use my method, then write underneath. Make sure you don't get negative numbers in there, because that would be terrible. And please tell me what you get. So this was x1, y1, x2, y2. This is negative 8, and this is negative 9. And this is 1, and this is 4. One more time. x2 is negative 8, x1 is negative 9, 1 and 4, 1 and 4. So let's do this together. Negative 8 minus negative 9. 1. 1 squared. 1. Plus 1 minus 4. Negative 3 squared. So d equals the square root of 10. Any questions?
Can you simplify that down?
I can't, because 10 is 2 times 5. There is nothing else. You cannot write it as 9 plus 1. You cannot split the radical if you write it as 9 plus 1 or something else.
Oh, what I was thinking was simplifying that down to just being 5.
The square root of 10 is not 5, because 5 squared is 25.
Yeah.
So the square root of 25 will be 5.
Yeah.
But the square root of 10 is the square root of 2 times the square root of 5, which cannot be further simplified. So this is it. You could approximate it. 3 point blah, blah, blah.
Yeah.
You could do that. But we're not asked to do that. We're only asked to find the exact. Okay. Adding, subtracting radicals. And we only have time for a couple of examples here, so we're going to stop shortly. Let's start with problem 5. 2 the square root of 50 minus 3 the square root of 125 plus the square root of 98. If you ask me, combine these like terms, combine them, I'll say, wait a minute, I have to simplify each radical, and then I'll tell you whether I can combine them. They may or may not be like radicals. I don't know. Give me a second, right? So I will look at 2 the square root of 50, and I know that I have to split 50 into... I look at 125, and I know that I have to split 125 into... There are 5 25s in there. Yes, 25 and 5. And I look at 98, and I know that I have to split it into... If I divide by 2, I get 49, right? So 49 and 2. I will rewrite the whole thing just to make sure I'm not missing anything. So I will write 2 the square of 25, the square of 2 minus 3, the square of 25 times the square of 5, plus the square of 49 times the square of 2. And I know what comes out of the radical. This will come out of the radical, and I get what? Good. This will come out of the radical, and I get. And this will come out of the radical, and I get. Good. So then, careful now. I have to multiply 2 by 5 and by the square of 2. What do I get? Very good. Here I have to multiply 3 by 5 with minus in front. So I have negative 15 the square of 5. The last one is positive 7 the square of 2. Now I look carefully and I'll say, oh, only 2 of these radicals are like radicals. One of them cannot be combined. 10 apples plus 7 apples, yes. But negative 15 the square of 5 is alone. So what will be the simplified form? 17 the square root of 2 minus 15 the square root of 5. Just one more and we stop. Let's say number 8, which is 2, the cube root of 3a to the 4th minus 3a, the cube root of 81a. Okay, I will split it first to the cube root of 3 and the cube root of a to the 4th minus 3a, the cube root of 81, and the cube root of a. A lot of work. At least one radical, I should say one radical in both needs work. Can I do anything to the cube root of 3? No. Can I do anything to the cube root of a to the 4th? Yes, I have to split it into a to the, yes, and a to the, good. This I cannot do anything. They are not even radicals. This is clear. But now I have to split 81 because the cube root of 81 is not an integer. 9 and 9 will not work. Say it again. Very good. 27 and 3. Now I will rewrite and have 2, the cube root of 3, the cube root of a cubed, the cube root of a minus 3a, the cube root of 27, the cube root of 3, and the cube root of a. I write this for safety. If you can skip that, you are allowed to if you want to. So this will stay, it will stay, but this will be simplified into what? This will stay, will stay, it will stay, it will stay, but this can be simplified into, good. Can anyone give us the first radical fully simplified? Two a, very good. And now these two together. The cube root of, excellent, minus. Nine a, so 9a, and these together. So notice one thing. The radical notation is identical. Same index, the same radicand. These two both have the same variable in front, and the variable has the same power. So now I can say 2 apples minus 9 apples? And the answer is? Sign? Very good. 7a, the cube root of 3a.
Wouldn't they cancel out?
Say it again. No, this is like
Oh.
saying 2 apples minus 9 apples is negative 7 apples. Thank you. If you have any questions.